In this topic, we will try to upgrade another level of basically analysis of our system. So let us try to recall what we have done. We have just solved Lagrangian, we have just formulated the Lagrangian, and once we have formulated Lagrangian, then what we have done, we have just used the concept of cyclic coordinate, and we can talk about the conservation of momentum and angular momentum mainly, as well as we can solve the equation of motion. So this is a wonderful formulation. But the real problem is that when we are talking about the Lagrangian, we cannot talk anything about the total energy of a system, whether it is conserved or not conserved. So it's another challenge for us, that how we will introduce the conservation of energy. And so what we have done, we have just go for a new formulation. So once we are just trying to get the new formulation that is known as Hamiltonian. And the beautiful part of Hamiltonian is that whatever with the information we have taken from the Lagrangian, we are just going to preserve it. So we have preserved all the information from the Lagrangian, and we can also analyze the total energy of a system with the Hamiltonian formulation. And now there is another challenge. If you will see the symmetry of a system, there may be n number of things which can be symmetric, which can be invariant, which can be conserved. For example, I think everybody have little bit of knowledge of this particular particle physics. You can see in a particle physics, we have different type of physical quantities as a very fancy name, a charm, beauty, and isospin, spin. There are n number of conservation principle, isn't it? I am just giving you an example that apart from momentum conservation, angular momentum conservation, and energy conservation, there may be some another type of symmetry. There may be some another type of invariant law. We have to just try to analyze it. So अभी तक तो ऐसा लग रहा था कि एक नया क्वांटिटी को समझना है, and then we have to just go for a new type of formulation. But the Hamiltonian formulation is so strong formulation that if we know the Hamiltonian of a system, and if we know the equation of motion of Hamiltonian, we can easily discuss any physical quantity, or we can easily discuss the time evolution of any physical quantity if we can write that physical quantity as a function of generalized coordinate and generalized momentum. Let's see what I am trying to tell you. So we will just try to solve all the problem mathematically, and then we will see how strong is your Hamiltonian formulation. In, I think, last classes, somebody have asked me that is that Hamiltonian is only for the discussing the energy. I think Pinaki have asked this question, isn't it? So if I can recall the voice, because I don't know what is face, so we can just judge you on the basis of voices only. Okay, so now I can in the position that I can give you the answer that no, Hamiltonian is the conservation of energy is one part of Hamiltonian formulation, but it is so strong formulation, it is so efficient formulation that you can analyze some another physical quantity, the time evolution of some another physical quantity with the help of Hamiltonian formulation. Let us try to go for it. Suppose I have some system, and if I can write the Hamiltonian of that particular system, that means I know the system completely, because I can solve the Hamiltonian equation of motion, and then we can see the time evolution of momentum as well as position. We have solved a lot of problem in last class with the time evolution of position and the time evolution of momentum. So let us assume we have some system whose Hamiltonian is given as, and this Hamiltonian is given as generalized coordinate, generalized momentum, and obviously time. So suppose we have this particular Hamiltonian, and if we have this Hamiltonian, then we have another equation of motion, that is Hamiltonian equation of motion, and which is del H upon del Qi is nothing but minus Pi dot, and we have del H upon del Pi is nothing but we have Qi dot. And we want to analyze a sum function. We want to analyze the sum function, and this function must be written. This function must be written as a function of generalized coordinate, generalized momentum, and time. And this is the same generalized coordinate, generalized momentum, because we want to analyze this particular function f for a system whose Hamiltonian is h. So actually what we want, we just try to see the time evolution of f. We just try to see the time evolution of f if I know the Hamiltonian of a system. So what we have to do? We have to just go for df upon dt. This is nothing but the time evolution of f. So we just want to know how this f is evolving with the time. And obviously, if df upon dt is equal to 0, then f is identified as constant. And you can find a new type of constant, and you can name named after some physical quantity. You can identify which kind of constant is that. Now, if we are just trying to find this df upon dt, then what will happen? Obviously, there is more than one generalized coordinate. So I can just go for del f upon del qi dqi upon dt plus del f upon del pi dpi or del pi upon dpi upon dt, and obviously f may be explicit function of time, so you can have del f upon del t. And now I have to introduce the information of system in this equation. So what is dqi upon dt? Is qi dot, and this can be written as del h upon del pi. So what we can do, we can write df upon dt is equal to summation over I del f upon del qi, and this is can be written as del h upon del pi plus del f upon del pi, and dpi upon dt is minus pi dot, so I can take minus in this side, so this will be minus del h upon del qi plus we have del f upon del t. And now this whole thing is a very important point, it can be symbolically represented as Poisson bracket. So what is your Poisson bracket? So let me use this space. So what will happen? We can write this particular thing df upon dt is equal to f h plus del f upon del t. And what is this f and h? The f and h is a Poisson bracket. This is nothing but identified as Poisson bracket, and which will be summation over I del f upon del qi del h upon del pi minus del f upon del pi del h upon del qi. So this is nothing but identified as what? Poisson bracket. So this is very famous thing which is identified as Poisson bracket, which is named after the scientist or mathematician. So that is the F and H. Now look at what is beautiful part. So here df upon dt is equal to the Poisson bracket between F and H plus del F upon del T. So, and this is one type of, in future, if you will go into quantum mechanics or even in classical mechanics, this is identified as some type of commutator. And what you can find that it is not the factor of only time that which will govern that whether the F is conserved or not. Rather, the if function is going to commute with Hamiltonian and the factor of time, these two will, in a combined sense, will tell you whether this function is evolving with the time or not. Are you getting my point? If you have any doubt, you can just ask me.
So please explain the meaning of commute means they'll combine.
Sorry.
So you said this F will commute with del F by del T. That means they both will combine.
F and H will commute means this will be equal to 0. Okay.
Okay.
Okay. If I am saying F and H will commute, that means Poisson bracket of F and H is 0. Okay.
Yes,
Listen what I am trying to say. Suppose I will ask you, suppose some function is, suppose this function is f, और इसको बहुत ही minutely समझने की कोशिश करो. Suppose this function is f and this is function of q, p and t. And I have this particular Hamiltonian of a system. And let's say Hamiltonian of a system is as a function of q, p and t. Maybe it is also function of time, it is also function of time. It may be function of time. Now question is that if f is an explicit function of time, is that it is necessarily a constant of motion?
No, sir.
No, it is not necessary unless until you have df upon dt is equal to not 0. For the conservation of any function f with respect to time or invariant of f with respect to time, only partial differential is not important. What is important that how this f is evolving with the time in a totality. And if I am talking about in a term of totality, then what will happen? This combined effect can be written as a Poisson bracket of f and h as well as a partial with the time. It may be possible, in the next class we will discuss this type of problem actually. It may be possible that your f is not an explicit function of time, but it is not constant of motion. It may be possible. And it may be possible that your f is explicit function of time and which is actually constant of motion. This is a wonderful thing. This is wonderful thing. And this can be incorporated in our analysis only due to fact of this particular equation of motion. So if you know the Hamiltonian, you know the equation of motion, you can easily formulate the Poisson bracket. And once you can formulate the Poisson bracket and you can know whether f is explicit function of time or not, and you can just find the combined effect of this thing to just try to just understand how this f is evolving with the time or not. So, but before going to next level of problem on some much more interesting problem, let's try to go for first the property of Poisson bracket, and after then we will try to today solve the basic questions related to Poisson bracket, and after then we will just try to see that how this all formulation is going to help us to understand the different type of invariant law, and you will find, and this is so strong thing, that it will a perfect connection between quantum mechanics and classical mechanics. It will try to give you the connection between the quantum mechanics and classical mechanics, which is very popularly known as in the quantum mechanics as Ehrenfest's theorem. So you can find that this will be remodified into quantum mechanics. And in general, in quantum mechanics, what we will do, we will just try to figure it out first, what is classical behavior of this, and then we will try to go for the quantum mechanical behavior of this particular physical quantity. But due to Ehrenfest's theorem, or due to this particular formulation, what we can do, we know the quantum mechanical phenomena, and we can just compare it with the classical phenomena. So why it is very important, and so why this Hamiltonian is actually incorporated into quantum mechanics. And this Hamiltonian is a wonderful bridge between classical mechanics as well as quantum mechanics. Are you getting my point? Everyone is comfortable?
Sir.
Okay.
Hello, sir.
So let's try to go for first the property and some basic problem. Okay.
Hello, sir.
Sorry?
Sir, am I audible?
Yes, you are.
सर फंक्शन जो हमने डिफाइन किया है तो h का जो मतलब वेरिएबल होंगे वही वेरिएबल फंक्शन
ऑब्वियसली क्योंकि आप तो उसी सिस्टम के अंदर ही, जैसे कोई भी एंगुलर मोमेंटम कंजर्व है या नहीं है, वो तो सिस्टम के लिए के साथ ही बात करोगे ना।
हाँ, यस सर।
सिंपल पेंडुलम के लिए तो बात, सपोज सिंपल पेंडुलम के लिए आप चेक करना चाहते हो कि एंगुलर मोमेंटम कंजर्व है या नहीं, एक सिंपल सी बात करते हैं। तो सिंपल पेंडुलम को आप जिस कोऑर्डिनेट सिस्टम में लिखोगे, उस पर्टिकुलर एंगुलर मोमेंटम को भी तो उसी कोऑर्डिनेट सिस्टम में लिखोगे।
हाँ,
या फिर अलग कोऑर्डिनेट सिस्टम में लिखोगे?
नहीं,
उसी में लिखोगे। कोऑर्डिनेट सिस्टम तो एक तरह से रिप्रेजेंट करने का तरीका है भाई। आप अगर हिंदी में क्वेश्चन पूछोगे तो मैं हिंदी में ही जवाब दूंगा ना। आर यू गेटिंग माई पॉइंट? एनालॉजी समझ में आ रहा है? एनालॉजी है कि जिस लैंग्वेज में आपने अपने सिस्टम को डिफाइन किया है, एफ को भी आपको उसी वेरिएबल और उसी लैंग्वेज में डिफाइन करना पड़ेगा। अगर आपने एच को पोलर कोऑर्डिनेट में लिखा है तो एफ को भी आपको किस में लिखना पड़ेगा? पोलर कोऑर्डिनेट में लिखना पड़ेगा। अगर आपने एच को आपने सिलिंड्रिकल कोऑर्डिनेट में लिखा है तो एफ को किस में लिखना पड़ेगा? सिलिंड्रिकल कोऑर्डिनेट में लिखना पड़ेगा। आर यू गेटिंग माय पॉइंट?
यस।
गुड।
And f can be any function.
F can be any function. You will surprise into next class. कल की क्लास आपके लिए बहुत ही ज्यादा सरप्राइजिंग होगा। Okay. F can be any function and you can name the function with your name. आपका क्या नाम है? आप अपने नाम पर फंक्शन लिख दो। कल मैं आप ही का नाम लेकर के एक फंक्शन डिस्कस करूंगा। Don't worry. Okay. You can just try to see whether it is constant or not. Are you getting my point?
Yes, I got it.
Okay. Okay. So let's try to go for our first. So if I am writing A and B, and A and B both can be written as a function of generalized coordinate and same generalized momentum. So this is nothing but summation over I del A upon del Qi del B upon del Pi minus del A upon del Pi del B upon del Qi. What is meaning of I? Generalized coordinate and conjugate momentum. If this is x, this is px. Are you getting my point?
Yes, sir.
If this is y, this is py. If this is theta, this is p theta. So it will depend on what is your generalized coordinate and what is your generalized momentum. Okay. Then obviously you can easily appreciate all these things. A and B is equal to what? Minus B and A. होगा ही, है ना? These all are trivial thing. What we have? A, B plus C is basically A, B plus A, C. You have A, B and C, and that is equivalent to A, C. You will put B, and in the classical mechanics, the order is not important. But in quantum mechanics, the order is always important because in quantum mechanics, they are actually operators. So I will request you that even in a classical mechanics, try to use this order thing. What is meaning of order is important. B is coming after A, and A is always coming before B. So here you will see the commutation between A and C, and B is after A, and plus you will go for B and C. Where should be A? Before or after?
Before.
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 So I will request you that always try to work this thing with a order, because they will not give you that it is quantum mechanical or classical mechanics. But yes, with the help of commutation, you can easily figure it out. And similarly, you can go for A, B, C is equal to A, B, C plus AC and B. Okay. And last but not the least, we have A, B. So this is Poisson bracket between A and B. And similarly, we will go for C. Now you will remember how we will go for next level. So ABC is the, you can remember the cyclic property of this. A, B, C. So suppose we are moving in a clockwise direction. So we are moving in clockwise direction. So first term is what? ABC. Now what should be the second term?
BCA.
BCA. So this is Poisson bracket between BC, and then you are taking the Poisson bracket of BC with the A. So this is the meaning of that. And what will be next one?
CAB.
CAB. CA and B. And this must be equal to 0. And this is very famous, identified as Jacobi identity. This is identified as what? Jacobi identity. Okay. And now in the examination, there are n number of questions can come from this particular. For example, if I will convert this thing C to B, then what I have to do? I will just going to replace C to B. Then what I have to do?
Minus sign.
Obviously, here I have to, this will be the remain same, and here I will just write C, B, and A. And this will remain same. Yes. So you have to, so in the examination, they will just ask you that which one of the following is correct. So what you will do, you will just write the first one, take anyone and write the first one as a cyclic part. And after then you will write the correct combination, and according to that changes, you can shift the minus and plus. For example, if someone will write A here and BC here, then what will happen? बताओ.
Sir,
ये
one
ऐसा ही है. A को पहले लिख दे, BC को बाद में लिख दे, तो क्या हो जाएगा? फिर से
minus sign, sir.
माइनस साइन हो जाएगा. और यहाँ पर A को पहले लिखे, CB को बाद में लिखे, तो क्या हो जाएगा? प्लस साइन.
Plus sign.
है ना? This will be A and CB. Are you getting my point? And this will remain same. So what you have to do, you have to always write the first trivial part, and after then according to choice of examiner, that you can change the plus and minus and everything you can easily adjust. Okay, clear है ये?
Yes, sir.
Okay, so let's try to go for some basic problem. Okay, just a minute. Chalo. So suppose let's go for first one. If R is a position vector and P is the momentum vector. So R is position vector and P is momentum vector. We have to find the Poisson bracket between R and P. Mod R and mod P. We have to find the Poisson bracket between mod R and mod P. So this was asked into your exam. So obviously R is position vector. So mod R is nothing but what?
Identity.
X square plus Y square plus Z square root under. And what will be mod P? We can write it in a Cartesian coordinate system. So mod P is the conjugate variable. So this is nothing but Px square plus Py square plus Pz square. Okay. Everyone is comfortable? Okay. And now we just want to find what will be the Poisson bracket between mod R and mod P. So what we will do? We will just go for del mod R upon del, and you can write Qi del mod P upon del Pi minus del mod R upon del Pi del mod P upon, this will be
QI.
I, this Qi, sorry, this will be Qi. By the way, what is Qi and Pi?
Generalized
XYZ.
क्या है यहाँ पर
Like-
Qi और Pi क्या है? X, Y, Z
XP.
is Q1, Q2, Q3. ठीक है? And what about your Pi? Px, Py, Pz. Okay. So how many term, if I am going to open this summation, how many term will be there? How many summation will be there?
3 summation.
3 summation. One is for X, another is for Y, and another is for Z.
Z.
Okay. So let's try to go for X first, and Y and Z will be trivial, same like X. So del mod R upon del X, del mod P upon del Px minus del mod R upon del Px del mod P upon del X. And similarly, we will go for Y, and similarly, we will go for Z. So this part is 0, isn't it? R is only function of X and P is only function of Px, Py, Pz. So this part is 0. What is del R upon del X? Del mod R upon del X? Can it is X upon root under X square plus Y square plus Z square? Am I correct?
Yes, sir.
Okay. So del mod P upon del Px is, similarly this is Px root under, this will be Px square plus Py square plus Pz square. This term is 0. So similarly, we will go for y and z also. So what is this particular thing? Can I write this is xpx upon mod r mod p? Similarly, what will happen to y coordinate? क्या आएगा? Symmetry देखकर बताइए. Because you can change x to y and y to z, so आपको कैलकुलेशन करने की जरूरत नहीं है. What will happen?
YP.
Y py mod r mod p. What will happen? Next,
PZ.
z pz mod r mod p. And what is this particular thing? Can I write this thing as r dot p by mod r mod p? लिख सकते क्या?
Yes, sir.
And what is this particular value? R cap dot p cap. Unit vector of r cap and unit vector of p cap, isn't it?
Yes,
Is that this value is 1?
Yes.
No.
Depends on the angle.
Depends on angle. Very good. It will depends on angle. Clear है ये?
Yes, sir.
तो ऑप्शन में 1 भी था. First option is 1 and second option is r cap dot p cap and third and fourth are some different options. So your answer is what? R cap and p cap. Clear है ये? Everyone?
Sir, I have a doubt.
बोलिए.
यहाँ पर आपने जो r del r और by r px का आपने वो वाले टर्म को जीरो क्यों किया सर? प्लीज एक बार एक्सप्लेन करेंगे.
आप खुद बताओ जीरो क्यों किया? डिफरेंशिएट करो मॉड आर को मॉड px के साथ.
ओके.
क्या होगा? बताओ. इसको मॉड px के साथ डिफरेंशिएट करो, क्या मिलेगा?
जीरो.
क्यों? क्यों क्यों?
तो क्योंकि वहाँ पे px से रिलेटेड कोई टर्म नहीं है.
है नहीं तो उसको क्या बोलेंगे? कैसे बोलेंगे? मैथमेटिकल टर्म में, मैच्योर टर्म में कैसे बोलेंगे?
So that value will be that variable is also zero.
नो नो, ये क्या है? ये ऐसे करके बोलोगे. आप कहोगे मॉड आर इज नॉट ए एक्सप्लिसिट फंक्शन ऑफ px. Are you getting my point?
Yes, sir. Now I got.
Okay. Good, very good. So एक आप होमवर्क करके दो, ठीक है? Find the value of a dot r and b dot p. Poisson bracket where r is position vector and p is momentum vector. A and b are constant vector. r क्या है? Position vector. p क्या है? Momentum vector. A and b क्या है? Constant vector. So this is your homework. आप लोग होमवर्क करते नहीं हो, एक दो बच्चे करते हैं, बाकी लोग क्या करते हो? चलो, सो लेट्स गो फॉर नेक्स्ट वन. कैसे इसको सॉल्व करोगे? कोई बताओ.
सर.
बताओ कैसे सॉल्व करोगे, क्या करोगे?
हाँ सर, इसके लिए ax ay az and bx by bz ले लेंगे and then ax x ay y az z. then
हाँ.
सर आराम से हो जाएगा सर ये.
फिर a को कांस्टेंट वेक्टर कोई मान लो, a1i
Yes, sir.
a2j a3k. r को तो xi कार्टेशियन कोऑर्डिनेट में सॉल्व कर सकते हो, तो xi yj zk. सो a डॉट r एक फंक्शन मिलेगा, सिमिलरली b डॉट p एक फंक्शन मिलेगा. फिर आप पॉइसन ब्रैकेट का इजिली यूज कर सकते हो. ठीक है? ओके.
Yes, sir.
नाउ चलो नेक्स्ट क्वेश्चन. The Lagrangian of simple pendulum is given by half m L square theta dot square plus mgl cos theta. So this is Lagrangian of simple pendulum. And what you have to do, you have to find the Poisson bracket between theta and theta dot. What will be Poisson bracket between theta and theta dot? What will happen to theta and theta dot? So Lagrangian is given. How will approach? कैसे करोगे?
सर थीटा डॉट का वैल्यू निकालेंगे लैग्रेंजियन यूज करके डेरिवेटिव ऑफ एल विद रिस्पेक्ट टू थीटा डॉट, तो पी थीटा का वैल्यू आएगा.
तो पहला केस क्या करना है? यू हैव टू राइट ईच फंक्शन. वेरी गुड, वेरी नाइस. तो लॉजिक ये है कि जिसका भी हमें पॉइजन ब्रैकेट निकालना है उसे हमें किस फंक्शन में लिखना पड़ेगा? लिखना पड़ेगा जनरलाइज्ड कोऑर्डिनेट और जनरलाइज्ड मोमेंटम के फंक्शन में. ओके, so we have to write it in a function of generalized coordinate and generalized momentum, and then we can easily use the Poisson bracket, isn't it? So first you have to go for Lagrange's equation of motion, or Lagrangian के formulation में जाना होगा. So del L upon del theta dot is equal to p theta, and from here ml square theta dot is equal to p theta. So what is your theta dot? Your theta dot is basically p theta by ml square. Now your theta dot is function of p theta, isn't it? So what you can use? You can write theta, and irrespective of theta dot, we have to write what? P theta upon ml square, isn't it? And what is my generalized coordinate? Theta and p theta. So what will happen? You will just find del theta upon del theta, del p theta upon del p theta minus del theta upon del p theta, del p theta upon del theta. So what is del theta upon del theta? 1. What is del p theta? Sorry, इसको del p theta मत कहो, ये गड़बड़ कर रहा हूं. Let us write this thing is a कर दो, है ना? a, इसे भी a कर दो, ठीक है? And this whole thing is a. Let us put this whole thing is a. Okay, this is 1. So what is del a upon del p theta?
1 by ml square.
1 by ml square. This is very important. Minus, what will be this value? 0. And this value is also 0. So what is value? 1 upon ml square. आप दूसरे तरीके से भी कर सकते हो. Theta and p theta. ml square is constant, so you can take outside this particular thing. So this is also property of Poisson bracket. So suppose you have a alpha b. Suppose alpha is constant, then you can find ab and you can write alpha here. Okay, so this is trivial thing. Now theta and p theta is what? Conjugate variable?
Yes, sir.
Yes or no? So if it is conjugate variable, then this value is equal to 1. You can easily get it. So you have to always keep in mind what will be qi and pj. If qi is generalized coordinate and pj is, so qi and pj, this is actually delta ij. You can easily figure it out. Okay, this is a very famous thing. So qi pj is delta ij. What is meaning of that? What is meaning of that?
If I equals to j, then
If
value
I
is
is equal to j, then this will going to survive, isn't it? Otherwise, all part is 0. For example, if I am talking about x and px, what will happen? What is
1.
value of x and px?
1.
1. Now I just want to find x and py. What will happen?
0.
0. Very good. Isn't it? If I am talking about x and py, then what will happen? This will be 0. Why? because x is another coordinate, is a one generalized coordinate. Py is generalized momentum related to y, that is not related to x. Are you getting my point? And this thing is also a source of uncertainty principle into quantum mechanics. In a quantum mechanics, you will find delta x into delta px is greater than h cut by 2. You will never find delta x into delta py is greater than h cut by 2. So you have to always work for what? Conjugate variables. Qi and pi, qj and pj. That will be remain one. So similarly, can you please tell me theta and p theta? What will happen to this one?
1.
1. But theta and p are
0.
0.
0.
Because theta is another variable and pr is related to r coordinate if I am talking about polar coordinate. Are you getting my point? So always you will keep in mind that only the Poisson bracket of the conjugate variable will survive, all other term will be 0. Are you people happy?
Yes.
है ना?
Yes.
So let's try to use this thing in some problem and try to give the answer. Okay, so this will be helpful for to solve the problem in a very shortcut method. So let's try to go for this. यहाँ तक clear है ना?
Sir,
हाँ बताओ.
sir, here why we write a comma alpha b equals to something right now? Why
This
we write,
one.
sir?
This one.
Yes, sir. Yes, sir.
Because alpha is constant.
Yeah.
So this is equivalent to this one.
Okay. Sir.
No, you can easily prove it. Look at here. Del A upon del Q, del alpha B upon del P minus del A upon del P, del alpha B upon del Q. Are you happy with this?
Yes, sir.
You can take alpha outside. You can take alpha common because alpha is constant. ले सकते हो common या नहीं?
Yes, sir.
Yes, you can take alpha common. And what you will get? You will get del A upon del Q, del B upon del P, del A upon del P, del B upon del Q. And what is this value? Alpha A and B. Okay?
Yes, sir.
Okay. Okay. So let us try to go for next problem, and you can use this thing into to solve the problem very fastly. Suppose there is Lz. Let's say this is angular momentum in z direction. Okay, and what we want, Lz is equal to x py minus y px. Suppose this is Lz. Now I just want to know what is the commutation between x and Lz. What will be commutation between x and Lz? You can directly solve this thing, but when you were going to directly solve from the first principle, then it will take unnecessary time. So we will solve this thing in a very shortcut method. So x Lz को क्या लिखेंगे? xpy minus y px, and this can be written as x xpy minus x y px. Okay, everyone is comfortable? And can I say this part is 0 directly without using any calculation?
Yes, sir.
Yes, sir.
Why? Because there is not any, if you are going to open it, what you will get? Suppose you are going to open it, then you have x and py plus x, py and x, isn't it? And what will happen to x and x? That is 0. What will happen to x and py? That is also 0. So you will just only search the thing that which one is going to survive. Here x and x is not going to survive, x and py is not going to survive, so this is directly going to 0. But here which term is going to survive here? Which Poisson bracket is going to survive?
YP.
Ypx. Huh? Which Poisson bracket is going to, if you are going
X
to
and-
open it, then what you will get?
X and PX
Sir,
will survive.
X, PX will.
X and px will survive. Very good. And y will be outside. The another term will be x and y, that will be always 0. And what will be x px?
1.
1. So that value is what? Minus y. Isn't it? So what you have to do, you have to just figure it out which one is going to survive. For example, let's go for a next one. Px and Lz. So here I am writing Px, x, Py minus y, Px. So if we are going to open it, then what will happen? Px, x, Py minus Px, y, Px. So which one is going to survive? In this, anything is going to survive? Is that anything is going to survive?
First answer.
Yes. Which one is going to survive? Px and x.
X.
And y will be outside. And here, which one is going to survive? Anyone, please tell me. यहाँ पर कौन सा survive करेगा? आप हिंदी में भी बात कर सकते हो, don't worry.
एक भी नहीं करेगा ना।
एक भी नहीं करेगा. Very good. So this will
Zero
be
आएगा.
0. So pxx की वैल्यू क्या होगी?
-1.
Sorry, x and this is py. This will be py. pxx की वैल्यू क्या होगी? -1. So -1 into px, the value is minus px. Are you getting this
That
thing?
is PY now.
Sorry, minus
Py.
py. Sorry. So this will be minus py. Okay, this is y. Are you getting this thing? Clear है ये? So take a homework and just try to figure it out. What will happen? Y Lz and py Lz. Just try to figure it out as a homework. Okay. So this is just a basic problems. We have just acquainted ourselves with the different type of basic problem of the Poisson bracket. So you have to always remember that conjugate variables are very important into classical mechanics as well as in quantum mechanics. And all these conjugate variables can be decided by the help of Poisson bracket. So suppose I will ask you that whether these two are conjugate variables or not, what you will do? You will just take the Poisson bracket of these two things and you will get what? They are what? Conjugate variables. Isn't it?
Yes, sir.
And finally, you will get into the canonical transformation from this particular, with the help of this particular definition. But in the next class and tomorrow's class, we will just try to figure it out. Again, the main purpose is still there, that we will just try to figure it out how Hamiltonian and Poisson bracket and the formulation of Poisson bracket help us to analyze a different type of symmetry in a system. Okay, so tomorrow's class is very, very important. Okay, so please, you have to go for the test. कितने लोगों ने टेस्ट दिया है? शुरू किया टेस्ट देना, एनरोल करना शुरू किया, एटलीस्ट एनरोल करना शुरू किया है नहीं? Listen, one thing is very important. You can ensure your result only when you will appear into test. Okay? So make a lot of effort to giving the test. सिर्फ क्लास करना इंपॉर्टेंट नहीं है, आपको टेस्ट भी देना पड़ेगा. खास करके ऑनलाइन के स्टूडेंट्स जो हैं, प्लीज कीप इन माइंड ऑल दिस थिंग. आप इस चीज को दिमाग में रखो कि आपकी लेवल तभी बढ़ सकती है जब आप ज्यादा टेस्ट दो. ठीक है? आर गेटिंग माई पॉइंट? है ना? बिकॉज अब वैसा नहीं है कि सारे लोग ऑनलाइन तैयारी कर रहे हैं. मोस्ट people are coming in offline as well as in online. So if people are in offline, obviously they have different leverages. ठीक है? वो दिन भर हमारे साथ लगे रहते हैं and I can see their copy, see their thing. But आपका improvement तभी होगा जब आप टेस्ट दो. टेस्ट तो उनके लिए भी इंपॉर्टेंट है, बट आपके लिए ज्यादा इंपॉर्टेंट है. ठीक है? क्योंकि आप डायरेक्ट कनेक्ट नहीं हो सकते हो हमारे साथ ना. वी आर इन द कनेक्टिंग आवर सेल्फ इन अ वर्चुअल वर्ल्ड. सो उसको और भी एफिशिएंट करने के लिए आपको टेस्ट देना ही होगा. ओके?
यस सर.
प्लीज अपना माइंड मेकअप कीजिए, है ना? और टेस्ट जरूर दीजिए. मैंने एक ब्लॉग भी डाला है अपने वेबसाइट पे, उसे पढ़िए. बहुत ही साइंटिफिकली एनालाइज किया गया है. ऐसा नहीं है कि जस्ट ऐसे ही लिख दिया गया है. डिफरेंट साइकोलॉजिकल और साइंटिफिक बुक्स को पढ़ करके तो फिर मैंने उस ब्लॉग को प्रिपेयर किया है. And that is not only for advertisement purpose, rather it is also for educate you that where is the actual problem lies. So the actual problem performance के पीछे यही है कि आप कितना ज्यादा से ज्यादा टेस्ट देते हो. ओके? लर्निंग इज इंपॉर्टेंट. पहला बात तो आपको लर्न करना ही होगा, सीखना होगा, बट सीखने के बाद आप एफिशिएंसी सिर्फ और सिर्फ टेस्ट से दे सकते हो. आर यू गेटिंग माई पॉइंट?
यस सर.
है ना पुनीत? समझ रहे हो मेरी बात?
यस सर.
तो आप क्लास करो अगर करने में मजा आता है तो, बट लेकिन उससे ज्यादा आप टेस्ट पर ध्यान दो.
यस सर.
ठीक है? क्योंकि अब आपको रिजल्ट चाहिए ना.
हाँ सर.
ठीक है? रिजल्ट चाहिए तो आप टेस्ट पर ध्यान दो. और एटलीस्ट सारे प्रीमियम टेस्ट तो जरूर करो. क्लास टेस्ट तो लगभग आपका हो गया है, जो पुराने स्टूडेंट हैं. जो नए स्टूडेंट उनका होता भी रहेगा, बट प्रीमियम टेस्ट तो सबको देना होगा. ठीक है?
यस सर.
ओके, चलो, सी यू टुमारो. थैंक यू.
थैंक यू
थैंक
सर.
यू सर.
बोलो.
Sir, sir, I have a doubt in the previous year class, the problem homework you give, GATE 2019 question.
दिस प्रोजेक्टाइल प्रॉब्लम.
Hello.
प्रोजेक्टाइल वाली प्रॉब्लम है ना?
Doing the problem.
Mhm.
Yes, sir.
So first,
Yes,
I
sir.
have deliberately given you this particular problem because you have to revise first what is your projectile. Okay? So
Yes, sir.
just go and revise what is the time period of your projectile. Okay? And what is the maximum height of your, what is x as a function of t in a projectile, what is y as a function of t in a projectile. So what you will do, you will first write the Lagrangian. So what will be Lagrangian? Half m x dot
Plane.
square plus y dot square, because it is in motion, is in plane. Okay?
Yes, sir.
And this is your kinetic energy, and potential energy is what? You can
MGY.
take mgy. Okay?
Yes, sir.
ठीक है? So you will take the potential energy, and now you can easily go for the time of the flight. है ना? t को आप x को और y को t के टर्म में लिखोगे. ठीक है?
Yes, sir.
तो वहां पर आपको प्रोजेक्टाइल के सारी चीजें यूज करनी पड़ेगी. ठीक है? सो फर्स्ट ट्राई टू गो फॉर द रिवीजन ऑफ प्रोजेक्टाइल एंड देन ट्राई टू डू दिस प्रॉब्लम. ठीक है?
सर,
और उसके
इसको हम लैग्रेंजियन इक्वेशन ऑफ मोशन से कर सकते हैं डायरेक्ट?
लैग्रेंजियन इक्वेशन ऑफ मोशन से आप कर सकते हो, अगर आप वहां पर x डॉट को v cos थीटा, वहां पर थीटा का टर्म भी तो इंक्लूड है ना?
यस सर.
हाँ, तो v cos थीटा के टर्म में ले जाओगे, y डॉट को v sin थीटा के टर्म में लेके
Yes,
जाओगे.
sir.
ये सारा करके फिर आप ट्राई कर सकते हो. ठीक है? बेसिकली इक्वेशन ऑफ
sir.
मोशन में अंत में यही आएगा आपके पास, ठीक है।
Yes, sir.
हाँ।
Yes, sir.
चलो, थैंक यू।
Thank you, sir.
थैंक यू सर।
थैंक यू।